web 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 ID web is a disturbance produced in a medium amada produced or disturbance whenever there will be web, and web will be in the form of pressure will be in the form of displacement will be in the form of electric field will be in the form of magnetic field will be and in the form of energy will be. So what is web? Web is any form of disturbance in a particular medium amada natraga to a particular object amada orsu yai ko kenta dakar ta de wave where the disturbance associated with energy will be known as wave, just like sound wave. Sound wave se kai dawi it is a disturbance, but this disturbance natro here sida aina puthoi ba sound gi wave sida disturbance ama create to the water na mo water sida when we drop any object. Let us take stone stone drop it will produce water wave produce that is also a kind of disturbance and the water wave will be known as ripple RIPPLE ripple. Understand? Now let us classify before studying this detail about wave equation, wave energy, wave. Let us discuss about the type of wave. This classification is very important. Okay, without knowing the concept of the type of wave, we cannot calculate our question unless we know the type of wave. We cannot identify the equation whether this will be progressive wave, or will it be stationary wave, or will it be longitudinal wave. When identify the type of wave set, there will be two different there will be classification lakini. Number one, on the basis of the medium requirement ki it will be classified as mechanical wave and electromagnetic wave. Mechanical wave will require material medium for its propagation, just like sound wave. Sound waves I sound produced. I am speaking right now, and the sound wave require air medium for its propagation. We must have at least a medium for the propagation of sound wave. Sound wave propagate medium if we are in space even though if I try to speak, okay, you will not be able to listen it. Let us consider we are in a space because there is no intervening medium between the listener and the speaker. Medium will be required. Medium for its propagation, and that type of wave will be known as mechanical wave, elastic wave. And what about electromagnetic wave? Electromagnetic waves for its propagation there will be no material medium requirement. Material medium requirement for example, when sunlight light light say it comes from sun and in between sun and the earth there will be vacuum. There is nothing at all. It can pass through the vacuum just pass through. That means it doesn't require any material medium at all for its propagation. That is why it is known as electromagnetic wave. Why electromagnetic wave? Because it consists of electric field, magnetic field. That is why it is known as electromagnetic wave. Okay, now on the basis of energy propagation, on the basis of transfer of energy, it will be progressive wave, stationary wave. Progressive wave means there will be actual transfer of energy. If energy is transferred from the point source to the receiver transfer of energy that will be known as progressive wave. Progressive to the energy will be transferred. And what about the stationary wave? Stationary wave it will not propagate energy, it will not distribute energy to distribute the we will be discussing stationary wave discuss the progressive wave to discuss the next. On the basis of vibration, mode of vibration transverse longitudinal transverse transverse wave will be like this. vibration mode will be up down up down up down to chakadiba, just like water wave. Water waves water waves produce stone drop down it will produce like this. So I produce the rock up down this will be transverse wave. There will be crest. See line this is known as min line min line ki this is amplitude, positive amplitude, negative amplitude. If the vibration mode is perpendicular to the perpendicular with the rock, vibration mode is perpendicular to the min line, then that is why we call this as transverse wave. Next, on the basis of vibration mode, we will have another longitudinal wave. Longitudinal wave we will be having compression, rearification, chalani, and the mode of propagation of waves like this. Back and forth up down perpendicular some regions it will have maximum density some regions real compression density will be maximum rearification your density will be very low alternate vibration some portion higher density, some portion low density alternate this will be known as longitudinal wave. And next time dimension. On the basis of dimension we are going to have 1 dimension, 2 dimension and 3 dimension. Can you give an example of 1 dimension? The 1 dimensional wave. 1 dimensional wave example this is very important copy example point of view string we take a string, okay? We take a string and we give a disturbance in the form of wave mode disturbance. From here we are going to conclude two very important concept masida sigi rubber sigi rope string we put one one rubber band mass one any object this is rubber band rubber band paper we attach something rubber we give disturbance then what is the mode of wave transfer? My transfer the mode of wave transfer will be like this. Do you understand? See rubber ribbon this ribbon will rise upward. Rise upward. Next time it will be again. So I like ribbon system is there any change in the position of the ribbon? Rubber ribbon there is only propagation of wave transfer but the particles min line rise that means the particle will only just oscillate while the wave will be moving in the proper direction. Do you understand the concept here? Yes, this wave is moving along one particular direction. Such type of wave that is developed on the string will be known as one dimension covenant. One dimension I have already explained one dimension. Why this is one dimension? Because it moves along one particular direction. One dimension. And concept point number 2 is that in any wave motion only the particle will oscillate. Particles oscillate. I am going to use two different terminology. Use the wave first the particle wave use the particle particle will only just oscillate and the wave will transfer from one point to another point just like this. Sigi thui ma string ama si wall ama da join the if you give a disturbance like this, final disturbance beam we have to propagate the before, but the particle doesn't change its position. Mark laser में position होंगे, it only just oscillate up down like as wave है it will propagate particle है particle will only just oscillate that will be discussed over here. That discuss the opinion next time two-dimensionality two-dimensional web will be developed over another developed a surface of developed just like water wave plane surface of the surface of the coordinate two-dimensional x y water surface this is a plane the water wave produced on its surface will be known as two-dimension colony. And what about your three-dimension example of only pyramid three-dimension the sound wave. See sound wave you three-dimension I sitting I back side to tie, right side to tie, left side to tie, up to tie, down to tie. In all directions the program the block. That is why sound wave will be in three dimensions. Now let us discuss about the wave. Nangi wave sida any form of wave liko. The here I even the particle oscillation and equal. This is y and this is your x and happening. Y will be considered as the displacement for the particle oscillation. We know that in your oscillation last chapter of oscillation discussed over in the oscillation chapter we have already discussed that y is equal to 0. This position will be known as mean position and right this is mean position, this will be your extreme position. This is also again extreme position number and it is going to oscillate up down like see y will represent the y will represent the displacement of the oscillating particle. And wave sida medium it will have particles there will be first particle, second particle, third, fourth, 5, 6, 7, 8, 9, 10 this is particle number 2 this particle number 2 cannot come to this position number A I has understand the particle number 2 is particle number 2 cannot be replaced with particle number 7 they cannot access their position. You may think that this is a wave, so this particle number 2 this particle 2 can reach up to 0.7. No, it will not change its position. Here the ribbon or the rubber band doesn't change its position. My position change it only oscillate up down oscillate like that. This particle will be particle number 2 will oscillate up down. 7 will also oscillate up down only one, but the wave will be moving in the forward direction. Wave it will be associated with energy the particle it is velocity it will be associated with momentum understand the I have wave motion you are going to consider the displacement of two number one the two object number one the displacement of the oscillating particle it will undergo oscillation like this whatever we have studied in your simple harmonic motion it will be again used for this particle oscillation just like this up down maximum velocity will be at the mean position maximum acceleration will be at the extreme position amplitude from here to here this will be also again amplitude understand next 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 let us consider for the wave we will be having one crest trough Lakra laktabra. The distance between two crests or distance between two troughs, it will be represented by lambda and it will be known as wavelength. Define wavelength. The distance between two crests or two troughs will be defined as wavelength, or in another language, your wavelength will be, wavelength is the displacement produced by the wave. Displacement produced by the wave. I am not talking about the displacement of the particle. Particle क्या है देखो, displacement of this x will represent the displacement of the wave, y will represent the displacement of oscillating particle. Okay, do you understand? Y the mana change होती है, कितना kan change होती है no, particle का change होएगा. X axis का change होगी. This is wave number 1, this is wave number 2, this is wave number 3. सब process तब रो चली. अदु along x axis का ना होता है. It will be considered as the displacement of understand? So the displacement produced for the propagation of one wave will be known as wavelength. From here to here, this is also again wavelength. And what is the time taken for the propagation of one wave? It will be known as time period. Time period. I understand. And this V will be represented, or V will be considered as speed of the wave. Speed of the wave. Wave speed of light speed light has a speed of 3 into 10 to the power 8 meter per second in air in space. Just like this, how we will be discussing that one. Sound 330 meter per second in air. Air the 330 wave, or sometimes 333 dollars. My space will be really good. Any wave will have its velocity velocity in this direction. Displacement of the wave velocity in this direction. This is the wavelength. Particle and this is for this is for your wave ke wave from here to here. This is how much lambda wavelength. From here to here, what is the angle produced? The angle produced is 2 pi. From here to here, what is the time produced? I know is a 3 parameter. Number 1, in the form of displacement of the wave. Displacement of the wave x. Number 2, that in terms of time taken. In terms of angle produced. Angle phase distance path difference. In terms of time, time capital T we will be having path difference in the form of displacement. Angle in the form of phase difference. In the form of time difference. Like we all know that your if we have to consider the displacement of the wave from this starting point to this point in the after time t, provided that this b is the speed of wave in the then what will be the displacement? Displacement is very simple. Distance is equal to speed into time. The distance produced by the wave from starting point to this point after time small t will be distance is equal to speed into time. Now let us go through some basic terminology. We can easily come to this. X is equal to Vt. I have already explained this. This is the displacement of the wave at any given time. Next, when the displacement is equal to lambda. When the displacement of the wave is lambda, what is the angle produced by angle produced? Angle produced will be equal to 2 pi tabra. This is why lambda will correspond to angle lambda will correspond to angle 2 pi. So one unit displacement of the wave will be this is the displacement of wave this is the displacement and this is the angle in terms of pi. Like so, lambda displacement of the wave will produce an angle equal to 2 pi. One unit displacement of the wave will produce 2 pi by kya rani, this is lambda mata taroidro, and this value will remain constant. My maming je k kawi k kawi, and this is known as k kawi nangi web number ma ko the bro ko yani ko web number adu di simu yo ai sunu kan ta okay siden simu kya tare one web. This is also again kya tare one web. So how many webs are there? Two. Yadra 2 lambda will represent 2 web. 4 pi will represent kya represent only 2 web. Yadra mitro yadani is khangani ko 2 pi by lambda hek hai ba tara ba kai company, that is web number represented by k. Yadra ai is khangani ko se jajo hai jajo tumning ni ro yani khangani si adudi mo next time ngasi in terms of when low is angle ka ai is the is ani ni ko. This is with respect to time and this is with respect to displacement of log the bro. One web is compared with respect to displacement. Sita kilani one web is compared with respect to time mo latri ne ba nangi with respect to displacement log matamda 2 pi by lambda comes out to be web number mo haira ba yare ko. Next time ngasi in terms of time the lakotara when the displacement is kya lakpa, when the displacement is lambda, when the displacement is lambda, what is the time taken? The time taken is capital T. The you put the value displacement x is equal to lambda velocity into time. V mapiro the lambda is equal to speed of the wave. Speed of the wave into time taken. This is formula number 1 for your lambda. That's for your velocity. Velocity kamai bitare. How will you write the velocity over here? Velocity of the wave will be equal to wave length divided by time period. Tabra tarani. See ka ekta lute ko se. Sir, to very easy ni. Haini na khale. Next omega se kai moving ko omega is known as angular frequency ka ko. We have already understand omega in so many chapters. Chapter chapter number 3, 4, 5. Repeatedly use now. So I don't have to explain this again. Explain to this way. Omega is equal to kya money 2 pi by t, and we know that 1 by t. That means 1 by time period will be equal to frequency ka manabra. This 2 pi f utarba. Yaraka. Now let us come to our wave equation. This is important. Wave equation any wave equation will be in the form of a function. It must contain both displacement term and time term. Ax plus bt among the provided that a and b are constant. A and B are constant. X na displacement of the wave ni, T is na any duration ni. Aduba provided that even though a given equation is in the form of Ax plus Bt, it may not be the equation for a wave unless y comes out to have a fixed value. Y value is fixed or the target dinner. Nangi wave function ni hybrid. Karigumba ax plus bt is lady colors. I nasika ngangs the confusion salam masya ko. Confusion sa tarawa yung high game mo. Example mo pigi mo. Y is equal to hatak yung mo. Ax ay na have metro. Sida suwanya yung 2x square ang mahapag plus matang sa kailangan na set b ito tabi lagi po. B height also this is 1 by t square ang mahapag kalazem ko. Will this be wave equation? Wave equation have started. You forget about that nangi magi power is the one libra. Power is the one ko. Power one and this is the power. The power dakar tadi. The power confusion sa tu na. Let us remove this. Power remove to thoge ko. Simplest thing is start of 2x plus 1 by t. This is in the form of kanai mong ax plus bt But what about a? A is kya manani? A will be equivalent to 2 ka manarba. Manare aduga kainosidi kya manani b ki value is kya manani b will be equal to 1 ga manabra manadabro. That means it must contain at least kana represent no at least two term la one containing x and another term containing t and you take whatever the value of x belonging to value low t value belonging below, but y must have some value khadi le gido baneba kya tabra value le taba undefined object kari hai. If the value of y comes out to be kya lava infinity lava, if the value of y comes out to be minus infinity tarva, then that will not represent the wave equation tabiyateva kanigba. If y is equal to kya tarva se y is equal to 1 tarva kya tarva y is equal to 0 tarva y is equal to minus 100 tarva value mo tar it will represent wave will represent the one yani ko when we put value t value is 0 after this kya tarani when we put t is equal to 0 kya taba t is equal to 0 bata rakhi we will have y is equal to 2x plus this is 1 by 0, this will be equal to infinity tabra tare. That means even though it is in the form of ax plus bt, this will not represent a wave equation. Understand the bra? I understand the miko. What is the basic criteria? What are the two important criteria for wave equation? Wave equation mo it must have two term ani level 3 ax plus bt am lego bani. Next for any value of x and the t y must have a fixed value lego bani, and it cannot have infinity and the minus infinity lego yaro undefined yaro yaga yare ko. Next ang yang asi wave velocity. This is the wave velocity with respect to our Canada velocity of the wave display kanoga wavelength time vector express the urat of the rock tawi. Now from the wave equation how will you find out wave velocity hai taragana coefficient of t sida coefficient of t la tabro coefficient of t, that is b divided by coefficient of x to that will be known as coefficient of x. Coefficient of t divided by coefficient of x will be equal to wave velocity yaga yarani ko. Adu next time wave ma direction mo le to iko ma direction de decide kamai to buni. If the two terms have the same sign, ma sign is manare ax positive or bt positive or bra or ax negative or bt negative or, that means both the term have the same sign level the wave will be moving in the negative axis the second wave yan tabra khangani ko. Aduga kaigumba if one term is positive and another term is negative tare, this term is positive, this term is negative, positive negative chatra jali adu itari the wave will be moving in which axis? It will be moving in the positive axis. Yagadre yaro jo yare haidadra haideko khangani se silu deko kebta. Now let us discuss about plan progressive wave ma tawrasi aduga we will start your calculation. Si maru ko yum chalaga halaga tang yenguso. Next time equation of plan progressive wave. Progressive ID kari aagi when aagi go progressive means it will be the wave will be able to transfer energy transfer tawam tari progressive wave ma aagi ko equation of plan progressive wave. Sila nang confusion sa tanong na. Let me give you one more insight ang tanapige. Sila tingin nga siya y is equal to a sine of omega t plus phi. Si kari equation sige siya. Si kari equation no ay si matatiya thami si kay no. Oscillation have na tro. Simple harmonic motion ay na have ba? Simple harmonic motion. Yan ko. Simple harmonic motion ki equation sida we have a is equal to amplitude and omega t is the phase and this is the phase difference like so this equation A equal to sine omega t, or we can also write like this is A sine of 2 pi by capital T times t into small t plus 5 like sida mag equation da we have only kana tam we have only time di tam like kanogi x ki tam yawdi adu tadi this will not be a wave equation. This doesn't satisfy wave equation. Ma wave equation omo oibagi satisfy tawdi. It must contain kana haba wave equation oigi y is equal to a function of ax plus b tm lakro. It must have kana lego tare nangi x tamam lego ni time gi tamam lego na tro. It contains only time gi tam to lakpani na. This simple harmonic motion is not a wave. Noi na ayam mo matag misconception na balay ko. Simple harmonic motion wave wala patara gadi it is a wave. That is wrong. Simple harmonic motion like patara su every simple harmonic motion is not kana gani wave we are there. But every wave will have kayo gani simple harmonic motion like gani. Ay haja understand daw mo bra. Wave puding magtina simple harmonic motion chatkani, but simple harmonic motion alone is not kana betare wave natte yagadra yarani ko adudi koina diagram ne use now what is wave haida adudi ya nangi particle ki consider tawda di for the particle it will be oscillating up down amla for the wave it will be displaced to the right hand side ma displaced chalabra chali adudi koina kari haiba nangi ngasai kaino sigi matungina di kamaila ani se sigi this will be oscillation la repo particle ki log tari oscillation aduga kaino ki log taraga ki log taraga na there will be the displacement along which direction, along a straight direction. In the chapanina we can call it as translatory motion and harsu abra wave basically wave se koina literally and the wave is the combination of oscillatory motion oscillatory motion plus translatory motion, because wave is going to transfer from the point source to point source to the receiver side in one direction the wave oscillation plus your translatory or linear motion. Understand oscillatory motion will be executed by particle na khangani ko aduga translatory motion ne kanana produce togani wave produce togani ya kadro yani ko siya lumala ko lu deko se the equation of plane progressive wave from hapaji y is equal to nangi a this is sine of omega t plus minus this is k of x plus find e the name man maming yan dai ko sidadi mo yamre adabre mo this equation satisfied wave equation or not. Yes, it satisfied magai no satisfied the reason because it has time gitamam yawa yawne it has kana gitamam yawne displacement gitamam yawa yaw ko kesi maming kai kawi wave number and hai ki right bro ke ki maming se wave number ko gi ni nang stay idu se mana where am higher ga sidoi bilamo where is na kai korni is equal to amplitude and high right bro amplitude yani ko se aduga kana haba omega is kya manani omega is equal to 2 pi by t equal to this is 2 pi f sine ke hagani se this is angular frequency angular frequency harus right angular velocity harus right temta ability ko how much of angle is being produced in one given second the angle kya produce the way that will be known as angular frequency or angular velocity yadra yare ko k is kai mane se k will be known as wave number ko bro k is known as wave number and this is equivalent to 2 pi by lambda siga mana nata si pawa te ko ai hore 2 pi by lambda da ko sidalang ma tar asa kaha se idea देखो the next time you phi is equal to this phi is known as initial phase at origin. Mana phase difference ko na phase difference yaw so yaw to yaw na phase ai dikhang mo mi bra ningjang mo mi bro phase ai ta di ko na oscillatory motion ta ko matam na this is A sina this is B ni na kalaji adu di A ga B le se kana na ahead or according to our rotation pattern matung ina if this is in the anti-clockwise direction sa pata radi B is ahead of A B is na A radi ahead of bro da bra or by how much of angle this is phi ma ta bra tare khang ni ko se khangi adu ita di man heading is a initial phase to finally present to rani ya ga da ya re ko now mathang da mu yeng asi sidagi mo sidala is no ne how will you find out nangi wave velocity kamai pho kani wave velocity v is equal to ta ro wave velocity je ke lagi ke daloge kai nuai to job ye wave velocity is equal to the coefficient of time t na ha right bro coefficient of time t divided by coefficient of now you know x ke ma ha right bro hai ki this is equal to omega divided by k la ka la oi yan tai ko se ai nga sai hai tu wave equation na mai ga na equal tham di du di the coefficient of t to the b divided by a to ke hai this is b and I right bro b can be whatever nang oining go be b is a constant a is a constant omega is also a constant at 2 pi by t this is a constant ma tai da na I understand to bro nang na according to the given question given equation ke matung ina di kai la ni se your b will be equal to kana mana tare coefficient of t that is omega divided by k is also a constant tabra you put the respective value and let us check it out whether our formula b is equal to lambda is equal to kya mana ba b t na ma lak tabra sita ta da tu check to ko zoom nom to eba si chum ni ko omega di kya mana ba this is 2 pi by capital t m la k की value जी क्या माने this is 2 pi by this is lambda am ta bro adu the after simplification lambda by t am ta ba adu here lambda find out to get t into b we get the same answer from the bra fangi ko as kya ta bro equation ye ka kan ran question pa ma ta ne we are going to find out what is the initial phase what is wave number what is angular frequency what is frequency what is amplitude just by looking at the equation we are going to decide it kya ta bro as kan ni ko atin nang next na si kamai ni fitare this implies that v is equal to omega divided by k where omega is angular frequency k is equal to sakhra mane spring constant kaira di pat sani spring constant harna te ko se oscillation ni k do not this is not the k that we have studied in your oscillation this k is wave number or wave angano and this is equal to kana mana ni se lambda by t ko mana no mana bro ya kata ya reko then y is equal to a this is sine of we can put like this omega is kya manava 2 pi by capital T ne iba bra this is small t plus this k is kamai iba this is 2 pi by lambda ina hape bro this is x plus pi ma iba bra yeah from here we can take out a this is sine of 2 pi common out and this will be t divided by capital T plus x divided by lambda plus pi ne e so ya ga ya ro itra hey da hey dekho so now let us do one question based on this equation sida tai se khangani ko warabo question number kind of jump to say question number 7 hana easiest question lagi hana usi quite like question lagi atang hybrid sine question number 7 the mana period is period y is equal to 10 to power 4 sine of 100t minus x divided by 10 and labra like velocity put where what is the velocity to where ada jaina hangi extra one hangi kan asigi kan direction ko rum jata ni. What is the direction of the wave? In which direction this wave is going to propagate? Positive axis na sa ni tayo ba? Maram di kay gino. If both the term is either positive or either negative ko itara di. Ani mo to positive? Both are positive or both are negative ko itara di. It will be in the negative. It will be in the negative la ani ko. Ato kali kumba amana positive ore amana negative ore kada si it will be in which direction sa patara positive direction. This is in the positive direction jaga to direction ni ko. Now omega ki kya mana ni se omega is equal to from here the coefficient of the t will be considered as omega, so omega will be 100. And what is the coefficient of x? X की coefficient तो क्या है ना? This is T हम हर बार तो T will be equal to क्या माना बा 1/10 हम लाग रहा लाइन क्या अंदाज़ को. Now what is wave velocity? Wave velocity is equal to according to question करी है wave velocity is equal to coefficient of T divided by coefficient of displacement हम height ना तो this is equal to ना इतनी ताकत है जो है ना morning का मुझे पूरा दोकी आता नहीं है कथा आता नहीं है इधर अंत जितना लाती जी वो ना से b is equal to this is omega km ला करना ला वो जो this is equal to 100 divided by 1/10 this will be equal to 1000 kaya tarani se meter per second mata का तार वो finish ये है नहीं था कशुलु उधर नहीं वेब सुनो ना पंगु तो लोगों मालूम करे अब देखो tarani Hello girl, I told music bono. Every thagi ये ना दूसरा है नो customer आए तो ये ना तुम हाई भाई नहीं क्या आता है 100 divided by 25 तारा बा finish लोग ये नहीं अदु नहीं ना हाई अब वाच अब को हाई गिटार दी live नहीं बा लोग ना पासु पाबी दे तासु पाबी दे अदु दिखाई दे this is equal to v equal to omega by k ना तो omega is 100 mana p is k is 20 p tadi this is 5 berapa ya ini kok hayang translation dari foto sih masih yo na sih kalau sih kelas 11 ki